I am so excited to be back. No, I'm not. All right, this is Unit 2, Lesson 5, Exponential Functions. If you're really bored, I have a lot of Easter eggs hidden in this that you can pause, but I mean, you'd have to be really bored, and isn't she lovely? Exponential functions are a nonlinear function in the form of y equals a times b raised to the power of x. This formula is going to be really important. Write it down. Increase exponentially. Get very big or very small very quickly. X is the independent variable and it changes by a constant amount, and y is the dependent variable and is multiplied by a constant factor. This should be vaguely familiar. We did this months ago. Okay. Exponential functions versus linear functions. Exponential functions form a partial curve. It's kind of a J shape or a flip backwards J that is bounded by an asymptote, a horizontal or vertical line that the curve gets infinitely close to but never touches. It almost flattens out, either horizontally or vertically. Linear functions are just a plain old straight line. Here are some more things that you can see that are different between them. On a table, a linear function has y values that increase and decrease by a common number, and it's just the same number all the time, where exponential functions have y values that have a constant multiplier or a common ratio. So they get like multiplied by like percentages or something to make it that J shape, where y values just increase or decrease, like add, subtract. Exponential functions are multiply and divide. On a graph, a linear function looks like a line and an exponential function looks like a curve approaching an asymptote. And in an equation, a linear function can be written in the form y equals mx plus b, whereas an exponential function is written in the form y equals a times b raised to the power of x. Here's a little check-in. I went and fixed these. I did, and look, it went away again. Oh my goodness. I guess we'll use IN today for our beauty. Our Mom Bob screwed up, and he is beautiful. All right, it pulled up again. What would happen if b equals 1 in the exponential equation, y equals a times b? See if you can figure this out. If you can't, it's okay, because we just barely started. Basically, it means that the function would be a linear function because y would equal a, not an exponential function. I will prove that to you because if b equals 1, then it's going to be a times 1, so it's going to be just a. So y is equal to a, and that's just going to be a straight line. We need complication in order to have an exponential function. Okay, here's example 1. We're going to go through this together. Don't panic. Determine if each table represents a linear function or, not for, an exponential function. That's going to drive me crazy. Okay, so there's actually 3 tables, but we're going to look at these 2 tables first. So how we figure out if they're linear or exponential is we're going to look at the rate of change between them. So here the x values are going up by 1. Okay. If you remember vaguely from months ago, we take this number, subtract this number, find the difference. That's 1. 2 minus 1 is 1. 3 minus 2 is 1. So this is plus 1 all the way across. Okay, and we do the same thing down here. We figure out the rate of change. 6 minus 3 is 3. 9 minus 6 is 3. So this is just increasing by addition steadily across, so that makes it linear. Linear is addition or subtraction, and exponential is multiplication or division. So this is telling us this is adding each time. So it's linear. Okay. Now let's go over here. If we do 5 minus 4, that gives us 1. If we do 6 minus 5, that gives us 1. If we do 7 minus 6, that gives us 1. So this is steady. Okay. If we do 4 minus 2, that's 2. If we do 8 minus 4, that's 4. Okay, this is not a steady rate of change. This is going to give us that curved increase that we're looking for, not a straight line. Well, that's not very straight, but you know, I'm me. So because we're multiplying, 4 divided by 2 is 2. 8 divided by 4 is 2. We're doing division down here, so that makes it exponential. Okay, let's go to the next one. Let's look at this table. So we have, if we're trying to decide if it's linear or exponential, so we have 0 minus 5, 0 minus a negative 5. So the difference between here is minus 5. The difference 5 take away 0 is just 5. 10 take away 5 is just 5, okay? So, I mean, really, except for this outlier, that's pretty steady. Okay, and then here we have 0.5 and 1. The difference between that is plus 0.5. And then the difference between 1.25 and 5, yeah, we're going to calculator that. Okay, the difference here is negative 0.375. So obviously this is not a nice pretty one, so it has to be exponential. Okay, the values increase by 5, so they're saying negative 5 plus 5 plus 5. Okay, I get that. So see over here where I said there was a negative, that's me not having a math brain. Ignore that, okay? And then these values are each multiplied by 5. So this is times 5, but by 0.05. By 0.05. I'm so smart, okay? Anyway, I got that it was exponential, and that's what it's asking. So whatever, we got it right. Graphing exponential functions, these are the steps to take. These should go in your notes. First step is to make a table of values by evaluating the function at different x values. You pick the x values, usually right around 0 because it makes it easier to graph. Second, you plot the points. Third, you connect the points with a smooth curve and be sure to identify the asymptote, or the point where it almost levels out. The fourth, I guess that's the only, there's just those 3 steps, but this should go in your notes too. Exponent rules, which I can never remember. Negative exponent rule is when your exponent is negative, it's equal to 1 over a raised to that exponent with a positive exponent, okay? A zero exponent rule, when your exponent is 0, is just equal to 1. And identity exponent rule, when your exponent is 1, it's just that number. I'm going to write this down because, like I said, I always forget. Okay, so example 2, we'll work through it together. Graph the exponential function y is equal to 3 times 2 raised to the power of x. So first, common x values to use when creating a table are x is equal to negative 2, negative 1. That should be 0, not a dash, I apologize. 1 and 2. However, any x values can be chosen. Create a table by plugging each x value into the equation y is equal to 3 times 2 raised to the power of x. So here we have our, whoa, I'm on completely the wrong slide. Eye candy time because I went to the wrong slide. Hee hee hee, hee hee hee. This is baby bread. I like baby bread, IN. This is the slide we should be on. So using the points that are right around 0, prime meridian, okay, we have negative 2, negative 1, 0, 1, and 2. So I'll show you an example of how to do this. So we're trying to solve for y. So we have y is equal to 3 times 2 raised to the power of x. And in this case, x is going to be negative 2, okay? So in PEMDAS, we do parentheses first, which is 2, and then exponents. So we're going to do 2 raised to the power of negative 2. Okay, so using our exponent rules, we have 3 times 2 raised to a negative is going to be the same as 1 over 2 to the positive. Okay, so we're creating a fraction out of this because of that exponent rule. So now we have y is equal to 3 times 1, 2 squared is 4, okay? And then when we're doing fractions, you multiply straight across. This is really 3 over 1. We just don't write it like that all the time. So 3 times 1 is 3, and 1 times 4 is 4. So the y coordinate here is 3 over 4, which is going to give you the coordinate pair negative 2 and 3/4. Okay, we'll go ahead and do another one so that you can get a better grip on what I'm doing. We'll do positive 2 this time, just to give a little bit different one. I'm pretty sure you don't need me to sit here and go through every single one. So if you do, comment and I will do that because I torture myself for you. And here our value is going to be 2. So now we have y equals 3. We do parentheses and exponents first, so it's 3 times 4, which is y equals 12. I love how every time on the 4 it does that. Makes fat little corner. I don't know why. So the answer here is, ooh, not there. Chonk, chonk. The answer here is 12. And our coordinate point here is 2 and 12. So you would do that for every one of these and get your answer, okay? And then if you come here, you can see here's my 212 that we figured out. And here is my negative 2 3/4 that we figured out. Okay, so it has all of the points now. So you plot the points on a graph. You should know how to do that. If not, GeoGebra will help you. And then you're going to connect them with the smooth curve. Notice that the curve is approaching the horizontal line y equals 0, but never touches it. Therefore, y equals 0 is an asymptote. And I don't, oh, right here, they're talking about this point. Because see here, it's still kind of going out. It's still going to keep going up and out. This is where it's talking about the asymptote. Okay. Let me grab my little slider. This exponential function is increasing exponentially. It's going up. Exponential functions can also decrease exponentially, and that would look like this, okay? Exponential functions. This occurs when the leading coefficient a is negative, okay? When a is negative, that's a decrease. Or when the constant multiplier b is in the range between 0 and 1. So it's like a fraction or a percentage. For example, the functions y equals negative 3 times 2 raised to the power of x, that's a negative a, and 3 times 1/2 x, that's when b is a percentage or a fraction, decrease. Okay, so you might need that in your notes at some point. You don't need it necessarily for this quick check or practice, but it's probably a good thing to know. Okay, example 3. 3 people have the flu, like a chimney flu. I'm doing so well today. Oh my gosh, have the flu at time t0. After 3 days, 192 people have the flu, which is why I still mask everywhere I go, because it's crazy. The population can be modeled by the equation p equals 3 times 4 raised to the power of t. Graph the exponential equation and find the population after 7 days. So first, make a table of values representing time and population. Keep in mind that time is never negative. So choose values such that t is greater than 0. We're not going to have -1, -2, because nobody had the flu before 0. Okay? So here's what our table is going to look like. We have day 0, day 1, day 2, day 3, and it provided us with the information that at day 0 there were 3 people, and at day 3 there were 192 people. That gives us those coordinate points. Okay, so now we need to figure out for day 1 and for day 2. Now, at day 1, we are going to have, this is also x, and this is also y, okay, which is why we have these coordinate points down here. So we're going to have p is equal to, we don't know, I gotta stop and think. I just love his happy little smile. I love baby bread, I-N. Okay, we don't know what p is, but we know what t is. So we're going to keep our 3, we're going to keep our 4, and now our t value is 1, okay? Which means 4 raised to the first power is just 4, so 3 times 4 is 12. So this becomes 12, and our point becomes 0. Oh, sorry, 1, 12. I'm getting distracted. I am squirreling. Okay, let's do this one. So p, we don't know the value. That's what we're solving for. But we know that we have 3 times 4 raised to the power of 2, which is right here. Okay, so exponents in parentheses first. 4 times 4 is 16. 3 times 16, I am totally getting my calculator because that is how I roll. 16 times 3 is 48. 48, okay. So, oh my gosh, that's beautiful, 48. So we end up with the point 2 and 48, okay. We've completed our table now. Let's make sure I didn't screw up. And we should have the points of 0, 12, and 248. So 0.12 probably reasonable, and 2.48. Yep, that looks good. Okay, so plot the points and connect the points with a smooth curve, which you can do either by hand or using GeoGebra. It's difficult to tell from the graph what the population will be when t equals 7 because it's increasing so quickly. You can see it's getting steeper and steeper and steeper and steeper. We can find the population at t equals 7 by evaluating the function at this value. So how we do that is we go p, which is the population we're trying to figure out, is equal to 3 times 4, and time is going to be 7 this time because that is the population, a week, the population that we're trying to find at a week. So 4 raised to the power of 7 is definitely a calculator problem. So 1, 2, 3, 4, 5, 6, 7 is 16,384. 16,384. And now we need to multiply that by 3 times 3, and that gives us our answer, which is 49,152. So after a week, that many people are going to be sick with the flu. Yeah, wash your hands, mask, I hate germs. Check in. Which of the following statements represents an exponential function? The number of people infected by the flu doubles every week. A savings account receives a $750 deposit every month. 5 cars pass through a toll booth every minute. An unpaid credit card accumulates 2.05% interest every month. So look at these, decide. There's 2 that are exponential and 2 that are linear. See if you can figure it out. These 2 are exponential because doubles is a multiplication problem. And anytime that you're dealing with a percent, you're dealing with multiplication or division. So it's going to be exponential. This one has a flat fee every month. So that's going to be a straight line linear. And this one is a flat number of cars per minute. So that's going to be a straight linear line. Okay. Here is question number 1 that you are going to do on your own because I believe in you. Graph the exponential function y equals 6 times 1/2 raised to the power of x. Pause the video, go do it, then come back and you can watch me be a moron because you know it's guaranteed. Alright, so first we need to make a table and have x values and y values. So we're going to start with the x value of -2. Okay, that's going to be our first point. And we need to find our y value for it. So we have y is equal to, oh, my puppy is getting off the couch and knocking over my lamp. I guess nap time is over. My puppy is like 100 pounds. He's a black-mouthed cur. His name is Moose. There's videos about him. I will try to remember to attach it. So this is -2. Okay, so we have y equals 6 times. Now, we have to make this a fraction because of the exponent rule. So I'm going to change this to a 0.5. So we're going to have 1 over 0.5 because a fraction over a fraction is just more than my left brainness can take. He's going to hit me in the face with the lamp. Okay. And he turned it on too. Oh my gosh. And he's tangled in it. Ow, my face hurts. Oh. Well, here's some more pictures because now I have a headache. This is Ian. This is Felix. Oh, my head. My face hurts. Let's see if we can continue now. Okay. So, okay. Ow. So now we have y equals 6 times 1 over, I know that 0.5 squared becomes 0.25. I finally learned that. Now that I'm 42 years old. Now we just multiply straight across. This really is 6 over 1. So we end up with 6 over 0.25. Don't get hit in the face with a floor lamp. It's not a good way to start your day. And we're going to bust out my calculator to do this. 6 divided by 0.25 gives us 24. So our first point should be 24. We should have -2 and 24. Let's do another point. Oh, now my other dog, my Great Dane, is coming to check on me. She's like, wow, is your face bleeding? Possibly, but you know, we're doing algebra, so it's okay. Let's do -1 And we go y is equal to 6 times, I'm okay, baby, 1/2. The Great Dane doesn't even love me. She's Dad Bob's dog, and she's that worried about me. Okay, so now we have y equals 6. My y looks like an x because I am a hero. And we're going to have 1 over 0.5. Oh, my face really hurts. Raised to the first power, which is just 0.5. So I'm not going to write that and confuse myself, because now I'm dealing with a facial injury. That becomes 6 over 0.5. Now, I'm this bad at math. I'm getting my calculator to do this. I think the answer is going to be 3, but that doesn't make sense because that's 6 divided by 2. 6 divided by... Oh, guess what? It's like multiplying. The answer is 12. I have a bachelor's degree. Yes, being me rocks. So these are the steps you take, and you're going to do 0, 1, 2 again. But we should have negative 2, 24, and negative 1, 12. So negative 2 is probably way up there. we can't really check it, but this is what your graph is going to look like. Yeah, I'm so good. My head hurts. Okay, this is question number 2. This is all you. A video is posted online and it goes viral. Not this one. The equation that represents the number of views the video got on each day is y equals 10 times 3 raised to the power of x. Create a graph of this exponential function that shows the views on the video for the first week. So that means we're going to have 7 days. Okay, go ahead and pause the video, do it, come back. So we're going to do the same steps as before, except this time, because you know it didn't show because I did negative 2 and negative 1. Oh, we're not supposed to do negatives because we're doing the days, we're doing the weeks. So I'm going to do day 1 and day 2. So if we have x equaling 1, we're going to have y is equal to 10. Wow, that's a special 10 times 3 raised to the first power. So 3 to the first power is just 3, so 10 times 3 is 30. So our first point should be 1 and 30. And then, let's see, grab my eraser. I'm going to do 7 because that one's a little bit harder. I mean, 2 times tables are easy even for me, you know, the math genius of the century. So we'll do y equals 10 times 3 raised to the power of 7. So this is at the end of the week. This should be our last point. So y equals 10 times 3, which raised to the power of 7, which is definitely my calculator. 1, 2, 3, 4, 5, 6, 7. And yes, I know there's a way to actually use the calculator appropriately, but I just go and do 3 7 times. Stop! Give me my calculator back. 2,187. 187. And this is 7, comma. I'm doing so good. So our first point should be 1 and 30, and our second point should be 2 and 187. 2,187. Well, I was way off because it's like 20,000. I'm so good. 20,000. Wow, oh, I didn't finish my problem. Because I just did the first bit. So I have 2,187. And then you times it by 10, and that would make it 21,870. I'm going to blame that on the head injury. So now it makes more sense because it should be up here in the 21,000 range. Blue-haired IN is depressed that I can't finish my math problems. But, you know, yeah, you got the general drift. I'm sure you're smarter than I am. If nothing else, I should boost your confidence. Here's question 3 that's all you. The value of a car depreciates exponentially each year. The value of the car can be modeled by the exponential function y is equal to 30 times 3/4 raised to the power of x. Graph the equation, then determine the value of the car in thousands of dollars after pause the video, do it, come back, see how stupid I am this time. Okay, so we're doing years, and we're going up to 10 years. So we'll just do a random one. We'll do 5. You should do them all. I know I'm not doing them all, but you really don't want to sit through a 3-hour video watching me do everything wrong. That's not helping anybody. So we're going to put our formula, and for x, we're going to put 5, okay? So grab my calculator. 3/4 is equal to 0.75. So there's 1, 2, 3, 4, 5. Okay, so that gives us a really big number. I'm just going to change it to 0.2373. 2373, okay? Y equals 30 times, I forgot it already, 2373. 0.2373, okay? And then we need to take that big old number, which I'm keeping the whole thing, so it may change. But it's now 7.119. We're supposed to do thousands of dollars. Now we have y equals 7.119. I don't know why this isn't thousands of dollars. I feel like I'm screwing it up already because I am such a genius. Let's go see if we have a 5 and a 7. That doesn't make any sense. So at 5, it should be about there, which is probably 7,000. Okay. So yeah, for whatever reason, that's 7,000 instead of 7.1. We're just going to roll with it. All right, let's do another plot point. Let's do 10 years this time. Yeah, just to torture myself. Why not? So we have y equals 30 times 3/4 raised to the power of 10. Write down the rest of my problem first, so I hopefully don't screw this up as much as I already have. All right, so let's go. 0.7, woo, hoo, hoo. 75. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm pretty sure I screwed this up, but we're going to say 0.5625. 0.5625. Oh my gosh, somebody can make a whole career out of doing the math right instead of what I do. And we'll multiply that by 30, and now it says 16,875. So y equals 16.875. So I'm assuming that's going to be around 1,687.50. Oh my gosh, that's beautiful. So let's see, at 10 years, it's going to be right around 1,000. Sure, we're going to say I was right and just move on. Practice question number 1, end of the lesson. This is all you. Just write your answer down when you get done with the whole thingamajigger. Then you can enter your answers instead of messing up the whole thing. Graph the function y equals 3 times 5 raised to the power of x. What is the y value if x equals 6? Pause it, do it, come back. I feel like I can actually do this one. It gives us the x value. So we're going to do y equals, sorry, sneeze, 3 times 5 raised to the power of x, which in this case is -6. We know what to do with negative exponents now. We go y equals 3 times 1 over 5 to the 6th, okay, which is 3 times 1 over 5 to the 6th. We have 1, 2, 3, 4, 5, 6. It's 15,625. Nice. 15,625. Because I love huge numbers. They just make me so happy. Like so much. Okay, so now we need to take 1 over 15,625. And we need to multiply that by 3. I don't think I did this right, but we're gonna, they say it's 0.000000192. Okay, I feel like I did this wrong, so you really should comment and tell me whether or not I got it right. Continue on, graph the function y equals 1/5 times 2 raised to the power of x. What is the y-intercept? So we're going to have to go through all of the things. Actually, I don't think we will. I think I actually know how to do this because we have an x value right here. So y is equal to 1/5 times 2. You should be doing this on your own before you watch me be a moron. Raised to the power of 0. Now, the exponent rule says that when something's raised to the power of 0, this just becomes 1. So we have 1/5 times 1, so y should just be 1/5. I'm pretty confident I got this one right because I'm a genius. Okay, quick check question number 1. I don't answer these because that would be cheating on your homework, and I'd probably get it wrong anyway. So it wants you to graph the function y equals 0.5 times 6 raised to the power of x. Identify the y-intercept. So remember from this one, when it's the y-intercept, we know that the x value is 0. So go ahead and solve this one and write down your answer. Quick check question number 2 says graph the function y equals 5 over 1/4 times x. Complete the ordered pairs for the x values of -2, -1, 0, and 1 by finding the y values. So you do what we've been doing and do it for -2, -1, 0, and 1. Those are all your x values. Create your little table. You'll get your y values, and then you figure out which one of these is right. Okay. All right, halfway. Writing exponential functions from a graph. So now we're doing it backwards. We had a function, we made a graph, now we have a graph, we're going to make the function. First, you pick 2 points on the curve. If possible, pick the y-intercept or the point 0a that intersects the y-axis. It just makes it easier. Number 2, solve for a, then substitute it back into the equation. Number 3, substitute the other chosen point for x and y with your value for a in the equation. Solve for b, and now that both constants are known, substitute the values of a and b into the standard formula. Okay, these steps should be in your notes. Example 1, we'll go through it together. Write an exponential function in the standard form that represents the graph. Use the rules for exponents. So the first thing we need to do is find the y-intercept and another point on the curve. The book chose 1/8 for their second point. Our y-intercept is right there, which is at 0, 4. So our 2 points now we have. Substitute the y-intercept of 0, 4 into the standard formula for x and y to solve for the problem. So 4 is our y value, equals a times b raised to the power of x, which is 0. We know that anything raised to the power of x becomes 1, so this is just a now, which means a equals 4. Step 3 is rewrite the equation with the answer for a, which is 4, and substitute the values for the second point, which are 1 and 8, to solve for b. So y now is 8, because that's our second point, is equal to a, which we know is 4, times b, which we don't know yet. We're trying to solve for that, raised to the power of x, which is 1. So anything raised to the power of itself is just b. So we have 4b. We're going to divide both sides by 4 because we're trying to get b by itself, which means that b is equal to 2. So now we have our value for b. Finally, substitute the constants a, which is 4, and b, which is 2, back into the equation in the terms of x and y. So we have y is equal to a, which is 4, times b, which is 2, raised to the power of x. And that's our final formula. Y equals 4 times 2 raised to the power of x. To ensure that your equation is correct, choose a third point to substitute and ensure equality. So the next point we'll choose, we need a nice pretty point. We're going to go right there. Whoops, I missed. So we already did 1/8. We can't have that nice pretty point. I'm going to go right. I'm so bad. Right there, we're going to say 2 and 15 this time. And that's assuming that I picked a good point because, it's entirely possible. Actually, why work that hard? Here's one right here. We have -1 and 2, and I won't have to use awful, awful numbers. So in this case, 2 is equal to 4 times 2 raised to the power of -1. When we have a negative exponent, it becomes a fraction, so it's 2, nope, 1 over 2 to the first power. So this is 1/2 now, because it just goes away. Everything's to the first power. 1/2 times 4 is 2, so we have 2 equals 2, and it worked. It worked. I got lucky. Okay, example 2 that will work together. The graph represents the rising cost of a gallon of milk X years since 2020. In 2021, a gallon of milk costs $3. I wish it was that cheap here. In 2021, a gallon of milk costs $3. In 2022, a gallon of milk costs $4.50. Write an exponential equation to represent the cost of milk y x years after 2020. Example 2. The graph represents the rising cost of a gallon of milk X years since 2020. In 2021, a gallon of milk costs $3. In 2022, a gallon of milk costs $4.50. Write an exponential equation to represent the cost of milk Y X years after 2020. So our first step is to find 2 points on the curve. The book uses 1, 3, and 2, 4.5. Substitute one of the points into the equation and solve explicitly for a. So how we do that is we're going to take this first point, 1, 3. So we have 3 is equal to a times b raised to the first power, which then gives us, did I do that right? Usually something gets eliminated. I'm not sure I did. Because this just is 3 is equal to a times b, which doesn't really help. Oh no, I understand. I remember now. So 3 is equal to a times b. We're solving for a, so we need to divide both sides by b. I remember this was the stupid one, which then gives us a is equal to 3 divided by b, because, you know, they want to make our heads explode. I remember that. Now substitute the second point into the equation. We know what a is, but we're not going to worry about that right now. We're going to take this and we're going to go y is 4.5, and it's equal to a times b raised to the power of 2. Okay, and that means we're solving for a still. So we're going to take the square root of both sides, I believe. No, we need to divide by b squared to get it alone. Divide by b squared, which is going to give us 4.5 divided by b. I remember this one because I was going through it when I made the slide and I'm like, this is ridiculous. So this is going to give us 45, the square root of, we end up with b squared is equal to 4.5, but somehow they ended up with different numbers, I remember. Maybe not, because there's no square root of 45. So b is equal to the square root of 4.5. Let me see if there's, because we're dealing with a point. 4.5, what's the square root? Yeah, it's a terrible number, like I thought. So we're going to say b is equal to the square root of 4.5 and go from there and see what it does. Either way, it's a nasty number. Maybe that's what they're trying to get across. Substitute the value of a from step 1 into the equation to solve, into the equation found in step 2 to solve for b. So we know that 4.5, if we don't get b by itself, is equal to a, which we found out was 3 over b times b squared. Well, b to the power of x, I guess. I'm just doing what they're telling me to do, and we're going to solve for b. So we need to... Really? Are we dividing 3 over b? This problem is nightmarishly hard. There's nothing like this on the quick check, so I'm just going to the next thing. It says we end up with b being 1.5. And I'm not even going to attempt to figure out how they got that. So, whatevs, my dear. They say they got a solution for b. We're happy for them in all of their smarticle particleness, okay? So they want you to take b and put it into the equation from step 1, this thingy, to solve for a. So if we have 3 over 1.5 is equal to a, then we'll grab our little calculator and we'll go 3 divided by 1.5 is 2, so a is equal to 2. Sure, if you say so. There's nothing like this on the end, so don't worry. Finally, write the equation with your new answers for a and b, which is 2 times 1.5 raised to the power of x is equal to y. Although this section focuses on writing exponential functions given a graph, note that the graph is not needed. As long as 2 points on the curve are given, an exponential equation can be written. Okay, your turn. You're not going to have to deal with anything like that. Don't worry about it. It's kind of nightmarish. In fact, I might just cut the whole thing from the video because why stress you? Write an exponential equation in the form y equals a times b raised to the power of x based on the graph. Pause the video, do it, come back. Okay, so the first thing that we need to do is we have 2 points. So we're going to take our first point and we're going to go 2 is equal to a times b raised to the power of x, which is 0. This right here becomes a 1, so we have a is equal to 2. Okay, that's our new information that we got. We solved for a. Next, we have, oh, it went too far. I apologize. Ignore that little flash. Okay, so now we take our second point, which is 1 is equal to, now sometimes it uses a and sometimes it doesn't. We're going to go ahead and put our value for a in. 2 times b raised to the power of 1. Okay, this becomes just plain b. So we are going to divide this by 2 and divide this by 2, which then gives us b equals 1/2, which means our final formula is going to be y equals 2 times 1/2 raised to the power of x. Boom! Look at that. I actually did it. Question 2. Write an exponential equation in the form y equals a times b raised to the power of x to determine the temperature of a cup of hot chocolate, y, after a certain amount of time, x, sitting outside, based on the graph. Then find the temperature of the hot chocolate after 10 minutes. Round to the nearest tenth of a degree. Your turn. Pause it, do it, come back. All right, so evaluate the function, and they gave us 2 points right here. I just blew this up. It was really little. So let's see here. We are going to take our first point, which is 130 equals a times b raised to the power of 0. Anything raised to a power of 0 becomes 1, so a is equal to 130. Okay. Then let's take our second point. We have 105.3 equals our value for a, which is 130, times b raised to the power of 2. Okay, so let's divide by 130 and divide by 130. Calculator time. 105.3 divided by 130 is giving us 0.81. 0.81 is equal to b squared. And if you take the square root of both sides, then you have b is equal to 0.09, which means our final formula is going to be y is equal to 130 times 0.09. I'm out of room. Squared. Let's go see if I'm right. Oh, look at that. Oh, well, it's not squared. It's x. I apologize. That's where I went wrong. There's your correct answer. Okay, end of the lesson. Practice question number 3. Which option correct exponential equation for the graph. Okay, pause it, figure it out, come back, we'll do it together. So first we need to start with 2 points on the graph. I'm going to go ahead and take our y-intercept, which is 0, 3. And the smallest number for another point that I can get that's easy, we're going to go 1 and 6. We're going to use those 2 points. Okay. Let's take our formula and we're going to go y is 3 equals a times b raised to the power of 0, which ends up being a equals 3. Okay, so now we have our a value. So we're going to go to our second point and we're going to go 6 is equal to a, which is 3, times b raised to the power of 1. So we're going to divide both sides by 3. And that's going to give us b is equal to 2. So our final formula should be y is equal to a, which is 3, times b, which is 2, raised to the power of x. So it's this one. And these may not be in the same order on yours, so don't just pick number 3 and assume you're going to get it right. Practice question number 4, given the graph of the exponential equation that goes through the points of 0, 6, and 1, 3, which option is the correct exponential equation for the graph? Pause it, figure it out, come back. Okay, our first point is going to be 6 equals a times b raised to the power of 0. So a is just 6. And then our next point is going to be 3 is equal to a, which is 6, times b, which is, we don't know, raised to the power of 1. Divide both sides by 6. b equals 1/2. So then we end up with y equals a, which is 6, times b, which is 1/2, raised to the power of x, which is right there. Okay, last practice question. Given the graph of the exponential equation, which option is the correct exponential equation for the graph? So we start with our 2 points. Here's our first point. So we have 6 equals a times b raised to the power of 1. And this is just 6 equals a times b. Now we did this. I have to stop and remember. So we divide. I remember now because we're solving for a. Divide by b. So a equals 6 over b. This is one of the nasty ones. Hopefully we can figure this out. Okay, and then our next point is 2 equals 6 divided by b times b raised to the power of 2. Okay, so we're trying to get b by itself. Interesting, interesting. I'm not quite sure where to go from here because we've got a b here and a b here. We need to get this 6 out of here. Well, these 2 will cancel out and just make a plain b. So we have 2 equals 6 times b. And if we divide by 6, then we have b equals 1/3. I think I'm getting there because that's one of the options in this. So then we end up with y equals a, which is 6 over b. They look the same because my handwriting's so good. Times b, which is 1/3 raised to the power of x. Okay, let me erase all this garbage and see if we have anything that looks like that. So we have we have 6 times 1/3 raised to the power of x, so I'm guessing it's going to be this one. Not entirely. Oh yeah, because it canceled out. I remember now. That makes sense. Okay, so it's there. And let's see. We're going to the quick check now. Which equation is modeled by the graph? This graph is kind of hard to see. So it looks, oh, the points are hard to figure out even where it's crossing. That's interesting. So what I would do, yeah, I'm going to help you a little bit on this quick check because it's hard to determine an exact majigger on here. I would go to GeoGebra. I would enter each of these and see which one looks like this. That is also a correct way to solve this problem. Quick check question number 4. Given the graph of the exponential equation, write the correct exponential equation for the graph. We have our 2 points. Go ahead and solve it. Figure out which one's right. And quick check question number 5. Given the graph of the exponential equation representing the value of a car since purchase, which option is the correct exponential equation for the graph if the graph goes through the points 0, 30,000 and 1, 22,500? So it gives us our 2 points. Go ahead and solve it. So now the question is, should I change the name of this series to Hot Mess Math with Mom Bob? Because I feel like I am just a hot mess all the time in this. I don't know. Peace out, guys.